Let's start by assuming that A does X units of work per day. Also assume that B does Y units of work per day and that C does Z units of work per day. Now let the total units of work be equal to W. Therefore, the time taken by A to finish W units of work is equal to W divided by X. Similarly, time taken by B would be W upon Y and time taken by C will be W upon Z. B and C together do Y plus Z units of work per day. Therefore, time taken by B and C working together will be W upon Y plus Z. Similarly, time taken by A and C working together will be W upon X plus Z. And time taken by A and B working together will be W divided by X plus Y days. Now we are given that time taken by A is equal to M times the time taken by B and C working together. Therefore, W upon X is equal to M times W upon Y plus Z. We are also given that time taken by B is equal to N times time taken by A and C working together. Therefore, W upon Y is equal to N times W upon X plus Z. And finally, we are given that time taken by C is equal to P times the time taken by A and B working together. Therefore, W upon Z is equal to P times W upon X plus Y. Therefore, to summarize, we have three results. W upon X is equal to MW upon Y plus Z. W upon Y is equal to NW upon X plus Z. And W upon Z is equal to PW divided by X plus Y. Take the first of these equations. W cancels across the left hand side and the right hand side. And cross multiplying, we get Y plus Z is equal to MX. Now add X to both sides. We get X plus Y plus Z is equal to MX plus X, which is equal to M plus 1 in brackets times X. Similarly, the second equation can be written as X plus Z is equal to N times Y. Adding Y to both sides, we get X plus Y plus Z is equal to N plus 1 times Y. And finally, the third of these equations can be written as X plus Y is equal to PZ. Adding Z to both sides, we get X plus Y plus Z is equal to P plus 1 times Z. From the above three results, we conclude that X plus Y plus Z is equal to M plus 1 times X is equal to N plus 1 times Y is equal to P plus 1 times Z. Let's assume that all of these are equal to lambda. Therefore, lambda upon X is equal to M plus 1, lambda upon Y is equal to N plus 1, and lambda upon Z is equal to P plus 1. Therefore, the ratio of 1 upon x is to 1 upon y is to 1 upon z is equal to m+1 is to n+1 is to p+1. This can also be written as the ratio of w upon x to w upon y to w upon z is equal to m+1 is to n+1 is to p+1. And notice that on the left hand side, w upon x is the time taken by A to complete the work, w upon y is the time taken by B, and w upon z is the time taken by C. Therefore, the ratio of the times taken by A, B and C respectively is equal to m+1 is to n+1 is to p+1, which is the required result. Now, using the definition of lambda obtained earlier, we can write x is equal to lambda upon m+1, y is equal to lambda upon n+1 and z is equal to lambda upon p+1. We had also obtained the result earlier that y plus z is equal to m times x. Substituting the values of x, y and z, we get lambda upon n+1 plus lambda upon p+1 is equal to m lambda upon m+1. Lambda cancels across the board and we are left with 1 upon n+1 plus 1 upon p+1 is equal to m upon m+1. Now in the first term on the left hand side, in the numerator, we add and subtract n, and in the second term on the left hand side in the numerator, we add and subtract p. Therefore, the first term on the left hand side can be written as 1 plus n upon n+1 minus n upon n+1. And the second term on the left hand side can be written as 1 plus p upon p+1 minus p upon p+1. And the sum of these two is equal to the right hand side, which is m upon m+1. This implies that 1 minus n upon n+1 plus 1 minus p upon p+1 is equal to m upon m+1. Rearranging this, we get m upon m+1 plus n upon n+1 plus p upon p+1 is equal to 2, which is the required result.